What's up guys, this is Masi. Welcome to my channel. In the previous video I was talking about the relationship between proton and hydroxide concentration in acidic and basic solution. Now I want to talk about the new term called pH or pH scale. And the reason we use pH or pH scale because the concentration of proton and the concentration of hydroxide is relatively small, and that's why we need to change it to a logarithmic scale, which is called pH. So because proton concentration in an aqueous solution is typically quite small, the pH scale provides a convenient way to represent solution acidity. The pH is a log scale based on 10, where pH equals to negative log H+, which means that the negative log concentration of proton. For example, when you sub 10 to the power of negative 7, it's going to be negative log 10 to the power of negative 7, and log of 10 to the power of negative 7 is negative 7, and we have the negative there, so negative times negative is going to return positive 7. pH and concentration. Since pH is a log scale based on 10, the pH changes by 1 for every power of 10 change in concentration of proton. So the pH decreases as proton concentration increases. So when we increase the concentration of proton, we're going to have more acidity and the pH reduces. So lower number for pH means we have more acidic solutions. And when we are dealing with the higher numbers, it means that we are dealing with less acidic solution or more basic solutions. So when we increase the proton concentration, pH drops. And for every 10 increase in proton concentration, the value of pH reduces by 1. And pH of the solutions are measured using a probe called pH meter. The pH of a solution is usually measured using a pH meter, an electronic device with a probe that can be inserted into a solution of unknown pH. And usually before measuring any pH, we need to calibrate it as well. There are some solutions with known pH, and we need to just clean probe before that and make sure it's dry, and then we submerge it inside the known solution. We adjust the pH if it's different from what you're supposed to have, and then confirm the number. So that's why it's going to be calibrated. So usually there are 3 solutions: pH 4, pH 7, and pH 10. So using these solutions you can calibrate pH meter. You need to be careful when you rinse it with water. It has to be completely dry before you insert it in solutions, because if it has drops of water, it's gonna interfere their calibration. Next example, when you want to calculate the pH and pOH. So first of all, I want to show you what is pOH and what is the difference between pH and pOH. So we learned earlier pH is negative log proton concentration and pOH is negative log hydroxide concentration. pH plus pOH is 14. So when we reduce pH, pOH increases. And when we increase pH, pOH reduces. So in this example, I want to show you how to calculate pH and pOH for each of the following solution at 25 degrees. A is 1 times 10 to the power of negative 3 molar hydroxide. B is 1 molar hydroxide. That's supposed to be OH minus. That's supposed to be H plus, not OH minus. So there's a typo in part B. It says 1 molar H plus. So the O is wrong there. So let's see how to calculate it. So for the first one, we have 10 to the power of negative 3 mole per liter hydroxide. So we can write this equation like that. Proton equals to Kw divided by OH minus. Kw, you remember that it was ion dissociation constant for water. So Kw is 10 to the power of negative 14 always for 25 degrees Celsius, divided by 10 to the power of negative 3 is going to be 10 to the power of negative 11 molar. So pH will be negative log 10 to the power of negative 11, so that will be just 11. And pOH will be the concentration negative log OH is going to be negative log 10 to the power of negative 3, or just 3. For the second one, OH is Kw divided by proton concentration, which is 1 times 10 to the power of negative 14 divided by 1, which is going to be 10 to the power of negative 14. So pOH will be 14 and pH will be 0. Next example, we want to calculate the pH of a sample of human blood. It was measured. It was 7.41 at 25 degrees Celsius. Calculate pOH, proton concentration, and hydroxide concentration of this sample. So we can say pH plus pOH is always equals to 14 at 25 degrees. So since pH is 7.41, pOH will be 14 minus 7.41, which is 6.59. And then based on that, we can find the concentration of proton and concentration of hydroxide. So pH will be negative log proton concentration. We have 7.41 equals to negative log proton. So log will be negative 7.1. And we can use antilog. Proton concentration will be 3.9 times 10 to the power of negative 8. And based on that, we can find the hydroxide concentration. We can say 10 to the power of negative 14 divided by 3.9 times 10 to the power of negative 8. That will give us 2.6 times 10 to the power of negative 7 m. So whenever we have the pH and we want to find the proton concentration, we need to use the antilog, or 10 to the power of minus pH. So 10 to the power of minus pH is going to give you the proton concentration, and 10 to the power of negative pOH is going to give us the hydroxide concentration. And pH plus pOH is always equals to 14 when the temperature is 25 degrees Celsius. I hope you enjoyed this video. If you found it useful, please like this video. You can also subscribe this channel to find lots of different videos regarding math and different topics in science. Thank you and have a great day.